Okay, this is a talk through of the very first question, in case you were struggling to remember how to approach a problem like this. We're asked in the first part to find an expression for the velocity, and we're given an expression for displacement, s. So the key to this question was remembering that velocity is the rate of change of displacement with respect to time. So I could say now my velocity v is equal to the rate of change of displacement over time. And just simply by expressing this, it's easy to see that I need to differentiate displacement. So if I differentiate with respect to time displacement, I'm going to get velocity, and it's going to be equal to the differential of 5, which is 0, as it's a constant, differential of 3t, which is 3, and the differential of negative 2t squared, which is negative 4t. I can say that my velocity then is 3 minus 4t. Part 2 of this question was to calculate the initial position and the initial velocity. So that word initial would indicate that the time is equal to 0. We can assume when somebody's asking for what's the initial velocity, initial acceleration, initial speed, we're always going to make time equal to 0 unless we're told otherwise in a problem like that. So when time is 0, the initial displacement is going to be 5 plus 3 times 0 minus 2 times 0 squared. So the initial displacement is going to be 5. We're not told any units, so we'll just leave it at that. And the initial velocity is again going to be when t is equal to 0. So it's going to be, if I call that v0, is going to be 3 minus 4 times 0. So the initial velocity was 3. And we're asked finally to find the position time when the velocity is 0, the time and position when the velocity is 0. Well, the velocity is 0. If we remind ourselves that velocity is v equals minus 4t. So 0 then would be 3 minus 4t if the velocity is 0. And so rearranging this, my time is going to be, it's perfect time for the lead to run out of my pencil. It's a new one. 3/4. And so I can substitute this value back into my position, so my displacement expression. So the displacement when time is equal to 3/4 is going to be 5 plus 3 times 3/4 minus 2 times 3/4 squared, which if we follow it through, it gives us an answer of 6.125. Typically we'd be giving units for all of these, but as the question doesn't give us any units, we have to just give those as our final answers. We could have perhaps have said unit time, so the unit displacement here, but that's all we could do. Hopefully that's refreshed your memories. Get in touch if not, and if you're still struggling.